Good morning. So last class, we went through this process called polynomial long division. And it's kind of a long drawn out process that builds off of the same algorithm that we use for regular long division with just numbers. And we ended that lesson talking about the pros and the cons. One of the pros was that it always works. And the other was that it resembles a process that you already know and you're familiar with. The cons is that it takes a long time to do. It takes up a lot of space. It's very error prone, and we'd be interested in an alternative. The good news is that there actually is an alternative, and that alternative is called synthetic division. Here at Atlantic Coast, we have a special name for it. So here at AC, we call this, and it'll make sense in a moment, drop mama. All right, and it's funny, and I think a lot of the teachers here do call it drop mama. It originated with Miss Spears, who taught here forever ago, and she kind of came up with this, and we all adopted it because it's very memorable. If somebody asks you, what did you do in Algebra 2 today? And you say, we did drop mama. It's very memorable. People will look at you funny. But if you go to another school, if you transfer out of Atlantic Coast at any point and somebody says, what were you doing when you left? And you tell them that you were doing drop mama, they will have no idea what you're talking about because it's really kind of an Atlantic Coast thing. So there are a couple of pros to it, and they're substantial pros. One of the pros is that it is much faster. In fact, you will be amazed at how fast you are able to do the division problems using synthetic division. Another huge pro is that it is space efficient. It's not going to take up a lot of space. Even if what you're dividing is actually really, really long, it's not going to take up a lot of space. There's a con, though, and it is a pretty major con. It only works for one particular form of division. So it only works if the divisor, this is the thing that's doing the dividing, not the thing that's being divided. It only works if the divisor takes the form of this, x plus or minus some kind of number. So I'll give you a couple of examples. For example, it would work if your divisor is x plus 4 or x plus 3 or x minus 2. It does not work if the divisor is 2x minus 1, although there is a way to get it to work with that. It's just you probably don't want to do it. It's not going to work if your divisor is x squared plus 2. And so it really only works for this form right here. It will not work if you have anything else as that leading term in what you're dividing, and it doesn't work for, like, say, a trinomial. If you want to divide by something like that, it will not work. Where polynomial long division will. Polynomial long division will work all the time. That that algorithm will work in every case. Now, here's the good news. I'm going to make up a statistic, okay? And I'm going to make up this statistic that says that probably about 90% of your division problems are this type. So, yeah, there we go. This type of problem. So while it is, synthetic division is very restrictive in when it works, it only works in cases like this. The really good news is this case is actually the vast majority of any of the polynomial division problems that you could ever possibly see, like ever. Okay. And so, yeah, so that's like really, really good news. So you could actually only learn synthetic division and you will probably be okay for the entire rest of your math career if you never ever do that long division process. In fact, there have been some years where I have not taught the long division process because it doesn't come up that much, and you can get to the answer so much faster using synthetic division. So what we're going to do is on the next slide, I'm actually going to redo out one of the long division problems from last class so that we have the long division in front of us. I'm not going to talk through it, and then I'm going to work the synthetic division problem side by side with it. All right, so what we have here is on the left-hand side, what I've done is, this is the problem that we were doing. I probably should have moved that down a little bit, but I thought it was going to take up more space than it did. So we had the problem of 4x squared plus 23x minus 16 divided by x plus 5. And last class, I went through this process where you take the x, you ask yourself, what do I multiply x by to get 4x squared? The answer is 4x. You multiply, you bring it down here, you subtract. And the final answer, if you recall, is this up here. So I'm going to copy it down here. Might as well use the space since I left it. And there's the final answer. On the right-hand side, that's the world's worst 5. I can do better than that. There we go. On the other side, I am going to do this with synthetic division, and then we'll look at the two processes side by side. As I am writing the synthetic division, I'll explain what I'm doing and why, at least to some extent, why it works, and hopefully it'll make sense. I'm going to do at least 3 examples before I release you guys to do some practice problems on your own. So for synthetic division, you will see different symbols used for synthetic division, and I actually use a symbol for this that is different from the other teachers in the school and different from what your textbook does. So I'm going to be upfront with that. I'm also going to put some lined paper on here. So I know that this side over here, I wasn't observing the lines, but I am going to observe some lines over here. So to begin your synthetic division, I like to set up essentially an upside down division symbol. And this is the symbol that's different. A lot of places will do like this, like your book will put it looks like that instead. I prefer like an upside down long division symbol. And then when you make it, you want to make it 2 lines deep, which is why I put the line paper. So we're going to have a row of numbers right here, and then we're going to have another row of numbers right here, and hopefully I'm able to write accurately on my tablet in that amount of space. And you shouldn't have any problem in your notebook. Now, across this line here, so this upper line, we are going to write the coefficients of the dividend, what we're going to divide, what the polynomial we're going to divide. A couple things you want to notice, make sure you include the sign. So this is going to be positive 4, positive 23, and negative 16. So we're just dealing with positive 4, positive 23, and negative 16. And you would do that for any polynomial. Make sure that you do put enough space in between the numbers so that they don't run together. You don't want this to look like 423. Okay, you want to clearly see like this is a 4, this is a 23, and this is a negative 16. Now, what you're dividing by, so if you kind of, look back over here to the left, we're going to divide by the x plus 5, but we're only going to take the constant part of that. And we're going to flip the sign. So we are going to, instead of a positive 5, we are going to put a negative 5. So you are going to use the 0, not the factor. I'm going to put that note, I'm going to like annotate that. So use the root or the 0, not the factor. Where in the polynomial long division, you were using the factor. In this, you are going to be using the root. Now, this is like super, super useful for a major reason. And that reason is because the most common spot where students make mistakes in the long division is in the subtraction step. So bear with me for a second. Remember that there's no such thing as subtraction. Like your first grade teacher lied to you. Subtraction just means adding the opposite. That's the definition of subtraction. So what we do in synthetic division is instead of putting like the positive and then doing subtracting, we're going to take the opposite, which is going to allow us to add, because all subtraction is adding the opposite. So if I go ahead and take the opposite, then I should be free to add. So now we get to drop mama. I'll click back over here. What on earth does drop mama mean? Well, drop mama works like this. You drop the first number, whatever the first number is. So if the first number is a 1, you drop a 1. If first number is a 4, you're going to drop a 4. So you drop the 4, like so. Easy enough. Everybody can do that. Then mama stands for multiply, add, multiply, add. So drop means drop the first number, and then mama stands for multiply, add, and pretty much you're going to keep doing that until you're done with the problem. So it might be drop mama, or it might be drop mama, or mama, 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 mama. You get the idea. You're just going to multiply, add, multiply, add, multiply, add, multiply, add until you're done. So the question you should be asking is multiply what? Add what? Excellent question. You are going to multiply the divisor by whatever number you have at the bottom here. So this first multiplication is going to be -5 times 4, which is going to give you 20. And then you're going to kind of bounce. So if you're looking anywhere other than at the screen right now, I need you looking at the screen. You're going to multiply down on this diagonal, and you're going to bounce up, and you're going to write the answer in this bottom line here. So we're going to do -5 times 4, which gives us -20, and we're going to write the -20 right here. And then we're going to add. So we have we're going to add going down. So 23 plus -20 is 3. That's pretty much a subtraction problem. So if it looks like adding, you're going to add. If it looks like subtraction, you're going to subtract, because you've got the signs already taken care of. That gives you a 3. And you write the answer down below. Now you repeat it, because it's drop mama. So we did ma, and now we're going to ma again. It's so much fun. Maybe if I can click over here. So you're going to take the divisor, and now you're just going to go look one unit over. So -5 times 3. And you bounce back up, and you put the answer right there. So -5 times 3 is -15, and the -15 gets written here. And then we're going to so we had mama. -16 plus -15 is -31. So kind of compare these two for a moment. First of all, this takes 3 lines of your notebook paper, 3 lines max. Always 3 lines. It will never take more than 3 lines to get the numbers in your answer. And you should notice some of the same numbers. Notice that we had a -20 over here, and we have a -20 in our work right here. Notice that we had the -15, if you look at where I'm circling, and there's the -15. We had a +4, +3, +4, +3. Here we have the -31. We have the -31. So you can really see when you look at the two problems side by side that the synthetic division does mirror the process of the long division. It just only deals with the numerical parts. Now you're not actually done with the problem, because this in the red is the actual answer. You've got a 4, a 3, and a -31. 4, 3, -31. You've got to take these numbers and you have to put them into the answer the right way. I have taught this different ways, and every year I kind of like change my mind in how I want to figure it out. And I guess I'll go with this. Whatever exponent you started with. So if you started with x squared, your answer starts 1 exponent lower, because you're dividing it. You're going like smaller. So this is going to be just x to the first power, because you always decrease it by 1. After x to the first power, you have your constant, and the number on the far right is always going to be the remainder. So your final answer is going to look like this. It's going to be 4x plus the 3, which is the constant, and then you always put the remainder okay, which was what we had right here, over the divisor. So plus negative 31 over the x plus 5. And of course, you can do, instead of plus negative, you could do what I did on the left there and just have the minus sign. Either is fine. So that was the first example of synthetic division where I'm explaining how to set it up, and we kind of really go slowly through it. The next two examples, I'm going to dramatically speed up the process. So let's keep this lined paper, which will probably help us out. The next one we're going to do is x to the fourth minus 2x to the third plus x squared plus x minus 1. And we're going to take that whole thing and divide it by x minus 1. So set up your synthetic division. It's going to make it 2 lines deep, backwards division symbol. And then across the upper line, you're going to write the coefficients. So we're going to have 1x to the fourth, negative 2x to the third, 1x squared, 1x, and then a negative 1 as the constant. So across the top, we have 1, negative 2, 1, 1, negative 1. Make sure that you do allow enough space between those numbers so that they don't run together. On the outside, our divisor, you're going to take this number and flip it. And I don't want you to get too confused with that, because next class we're going to talk about sometimes when you don't flip it. Okay, so it's a negative 1. We're going to use a positive 1. And now we engage drop mama. We're going to have more than just mama this time. We're going to have like mama, 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 mama. It's just fun to say. Mama, 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 mama. Okay, here we go. Drop the, oops, I didn't mean to do that. You guys can't even see what I did. Drop the first number, whatever the first number is, drop it. So you drop the 1. Now we multiply on the diagonal here. So 1 times 1 and then bounce up. 1 times 1 is 1. That's Now we our way down. Negative 2 plus 1 is negative 1. Along the diagonal. 1 times negative 1 is negative 1. 1 plus negative 1 is 0. Ooh, Miss Taylor's favorite number. 1 times 0 is 0. And we bounce back up and we do the 0 here. 1 plus 0 is 1. And 1 times 1 is 1. And we write it here. And then negative 1 plus 1 is 0. So we've got this like what's called an iterative process. We just keep repeating it. Ma, 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 ma. Ma, 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 ma. Now we're not done with the problem. What we have here is just a row of numbers. We need to make sure we put the variables back in because we have a polynomial divided by a polynomial. The answer is another polynomial. Remember the rule. Whatever the exponent was, the answer starts 1 less than that. So if my original problem started with x to the fourth, my answer is going to start with x to the third. Then it's going to go down to x squared, then x to the first, which of course is just x, then the constant, and then the very last thing is the remainder. So when I go to write the final answer for this, it's going to be 1x to the third minus 1x squared plus 0x plus 1 plus 0 over x minus 1. So immediately you should probably look at that and say, this seems like you wrote some extra stuff. Well, yes, I did. Now, there's nothing wrong with how I've written the answer. I just went textbook, like plug in the numbers everywhere. But yes, we did write some extra stuff. For example, you don't need to write a coefficient of 1. 1 times x to the third is just x to the third. So you could just write x to the third. Same with the 1x squared. You could just write minus x squared. 0 times x is just 0, so that doesn't need to be there at all. So we can go over to the plus 1, and then we've got 0 divided by x minus 1. Well, 0 divided by anything, if I don't have like any pizzas to give you and I divide the pizzas equally, like you're not getting anything. So that's just a 0. And so you could write the answer is just x to the third minus x squared plus 1. I am not going to mark off on anything if you leave all that stuff in there. So if you're just more comfortable leaving it in, that's fine. But feel free to clean it up. Like, yes, we didn't need to write all that stuff. last practice problem or example problem. And this is going to bring everything kind of full circle with the going all the way back to the very first lesson coming back from the break. So this is our problem. X to the fourth minus 6x squared minus 27 divided by x plus 2. And here's the deal. We have x to the fourth, and then we jump down to x squared. And if you think back to that very first lesson in that very first homework assignment, one of the things I asked you to do was to write your polynomial in standard form with the missing terms. And what I said at the time was, it's not important right now, but it will be important for a future lesson. That lesson is here. This is x to the fourth. There is no x to the third, so you have to put it in. 0x to the third minus 6x squared plus 0x, okay, because you have the x to the first, minus the 27. The reason why you need to do that is because when you set up your synthetic division, you have to include those zeros. You have to include the spot for the x to the third term because your answer might have x to the third or x squared in it, and you have to reserve the spot. If you do not put those zeros in, then you're going to be missing whole chunks out of your answer. So the numbers would go 1x to the fourth, 0x to the third, negative 6x squared, 0x, and then negative 27. And then make sure that you are flipping the sign on the divisor. And now we go through drop mama. And it's really fast now that we've seen a couple of these done out. Drop the first number, whatever it is. So in the first problem we did, the first number was a 4. Sometimes we see the ones so often that you start to think it's always going to be a 1, but it's whatever the first number is. Then we, negative 2, write it up here. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Negative 6 plus 4 is negative 2. Sometimes people will do this. They'll do 4 minus 6 instead. Whatever works for you. Negative 2 times negative 2 is positive 4. 0 plus 4 is 4. Negative 2 times 4 is negative 8. And negative 27 plus negative 8 is negative 35. And you will get very, very fast at this if you practice it. Like, you will just get really fast at it. Remember that this is not the answer. We do need to put the variables back in. If the original problem started with an x to the fourth, then my answer is going to start with x to the third, and then it's going to go down to x squared, and then x to the first. Then you'll have the constant, then you'll have the remainder. So my final answer for this is going to be 1x to the third minus 2x squared minus 2x plus 4. And then you can either do plus negative 35 or you can do minus 35 over the x plus 2. That has to be your final answer. And that is synthetic division. Most of the time, if you have to divide polynomials, this is going to be what it looks like. So we did several things. So we went through the process. We compared it with the original, like long division, so you can see the similarities. We did one where we ended up with the zeros in the answer and how you can clean that up. And then we did one where you had to put the zeros into the problem with the missing terms. The only thing that remains is for you guys to get a little practice on your own. So I'm going to put a couple practice problems on the next slide and then we'll work them out. Okay, here are the 2 practice problems. I'll give you a moment to write these down. If we're doing this in class, I'll probably want to switch over to the document camera. So take a picture of them or quickly copy down both problems and then start working them after you've copied them both down. So if I do take them off the screen, you will be okay. For those of you rewatching at home or watching the lesson because you're not in class, I will work the problems out very quickly on the subsequent pages. Right, here's this first one, and so I'm going to go ahead and set up my synthetic division. My coefficients are 1, negative 7, and positive 20, and then I'm going to flip the sign on the divisor. drop the 1. Negative 4 times 1 is negative 4. Yeah, negative 7 plus negative 4 is negative 11. Negative 4 times negative 11 is positive 44. 4, great, these numbers are getting too big. 44 minus 7 is 37, I hope. Negative 4, I should have done this out ahead of time, and I took all my calculators to work. What is that? 148? Seriously? Okay. Negative 148, and then this is negative 128. I really hope I did this right. And then my answer started with the cubic, and so it's going to start, my final answer is going to start with the square, and then an x, and then the constant, and then the remainder. So my answer will be 1x squared minus 11x plus 37 minus 128 over x plus 4. And I don't have the answers in my notes, so well, my mom will watch it and she'll let me know if there's a mistake. All right, here's the next one. So for this one, go to set up my synthetic division, and notice that we are missing the x cube term on this one. So when I go to do my coefficients, I'll have 1x to the 4th, 0x cubed, negative 5x squared, 4x, and 12. And then, of course, I'll flip the sign on that divisor. And now we drop mama. Drop the 1. Negative 2 times 1 is negative 2, plus 0 is negative 2, times negative 2 is positive 4, minus 5 is negative 1, times negative 2 is 2, plus 4 is 6, times negative 2 is negative 12, and I get a remainder of 0. That's kind of nice. My original polynomial started with x to the 4th, so my answer is going to start with x to the 3rd, and then count down from there down to the remainder. You should always start one exponent lower than what you started, and you should always end on the remainder. If you end somewhere else, you've made a mistake. So my final answer here is 1x to the 3rd minus 2x squared minus 1x plus 6, and there is no remainder. So hopefully that serves as a check on these problems, and then all that's left is the homework.